Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we would talk about ISIS multi-topology. Now in multi-topology basically there are two separate protocol stacks, two separate SPFs run, separate for IPv4 and separate for IPv6. They both are independent of each other. So an IPv4 path could be a separate path, an IPv6 path could be a separate path, because they're completely independent of each other. Two separate databases are going to be basically maintained, and SPF is going to be run separately for each other. Now, when would you normally run multi-topology? Typically, multi-topology is used when you have an IPv4 to IPv6 migration. So let's say you already had IPv4 and you want to slowly migrate to IPv6. So IPv6 is introduced into your network slowly. And while the migration is happening, you keep IPv4 separate, you keep IPv6 separate. Once the migration is complete, you can then move to single topology and have it on a one-to-one basis. One thing that you must remember is Cisco iOS XZ routers, they basically run single topology by default, and iOS XRV, they run multi-topology by default. So here is an example where if you do a show ISIS database, you would see multi-topology. You have separate for IPv4 and separate for IPv6. One thing that you must remember is for multi-topology information to go in the database, you must have metric style wide enabled. Otherwise, you would not see your multi-topology in your database. So let's quickly implement this on our routers. I have 6 routers, 6 iOS XZ routers and 2 iOS XR routers. I have already pre-configured ISIS on all the routers, and they all are running level 2 adjacency with each other. I have not configured any metrics at this point of time, and they all are running single topology at this point of time. So I would go back to all my iOS XZ routers and move them to multi-topology and enable metric style wide. The next thing that I would do is disable single topology from XRV, because right now it is configured with single topology. Again, I'm going to repeat the same thing again, that XRV or XR routers, they have multi-topology by default. But right now I have configured them as single topology. So I would move them back to multi-topology, and then we would look at the database again and see which path IPv4 is taking, which path IPv6 is taking. At the same time, we would go and ensure that traffic for IPv4 goes from the upper path and traffic for IPv6 goes from the bottom path. Which means if I do a ping from router 1 to XR2 for IPv4, it should go from router 1 to 2 to 3 to 6 to XR1 to XR2. If I do a ping for IPv6, it should go from 1 to 2 to 4 to 5 to XR1 to XR2. So let's quickly configure this on our routers. I'll start off with my iOS XZ routers. So on R1, if you look at my configs, show run section router ISIS, I have enabled ISIS, my loopback is passive interface, and I have IS level 2 only. I don't need to say single topology because that's default on iOS XZ. If I have to change this to multi-topology, I have to define that on another process and also change my metric style to wide. So right now, if I do a show ISIS database and look at the database of the neighbor, let's take one LSP ID of any one of the router, maybe XR2. And if I look at this information here and look at detail, you can see that I have both the address families and I have single topology running. So even if I go and change this to multi-topology, for multi-topology to go in the database, I must have metric style wide. Default is narrow. So let's go to config T and say router ISIS and go to address family IPv4, and in fact it gives me a warning which says that I must configure metric style wide to go to address family IPv4. So let's do that first. So metric style would be wide, And then I can go to address family IPv6, in fact, and change this to multi-topology. That's all I need to do on router 1. I have already pre-configured all my routers to have ISIs activated for both IPv4 and IPv6, which you can see on my interface gig 1.12. I have IP router ISIs and I have IPv6 router ISIs. The only difference is that now I would have two separate databases for IPv4 and IPv6. So let's do a show ISIs database again. And here I can see that I have metric for IPv6 and I have metrics for IPv4 separately. If you look earlier, I had exactly the same information earlier also, but the changes that you would see would be after you configure all the other routers also. Right now I have only configured router 1. I have to still configure router 2, 3, 4, 5, 6 and XR1, XR2. So let's start off with R2 now. So router ISIs, metric style would be wide, and then address family IPv6. Here I would say multi-topology. Same thing on 3. Let's in fact copy paste from router 2. So metric style wide and multi-topology. So let's go and copy this part. So let's go to R3, router ISIs. I have metric style wide and address family IPv6, which has multi-topology. Then I have router 4, five, and finally R6. So now all my iOS XZ routers are done. Now I need to go back to my XR1 and XR2, and that's where I would go back to multi-topology, which is by default it is, but I have changed that to single topology at this point of time. So looking back at XR1, if I do a show ISIs database for XR1 right now, I have single topology running right now. I have both the address families, but I have single topology running right now, so single database. So I would go back to XR1, router ISIS1, and go inside address family IPv4 unicast, and here I would say metric style wide. Same thing I would do for IPv6, change this to metric style wide, and then say no single topology. The command is different for XR routers. You don't say multi-topology, you say no single topology, because default was multi-topology. And I had changed that to single topology, so you just say no single topology. And let's do a commit. The minute I do this, if I look back at my database, show ISIs database, and let's take router 1's LSP ID and give detail, you would see that I have multi-topology running separately for IPv4 and separate for IPv6. And I have separate metrics for IPv4 and separate for IPv6. Same thing I would need to do on XR2. So router ISIS1 and address family IPv4, metric style would be wide, address family for IPv6, metric style wide, and no single topology. Let's do a commit. So even though I'm right now running two separate databases for IPv4 and separate for IPv6, my SPF is separate for IPv4 and IPv6, but right now I'm actually doing load balancing. So now if I go and change the metrics, IPv4 and IPv6 would follow a separate path. So if you remember in the single topology video, we were changing the metrics of the links by giving ISIS metric command, and that would change the metric for IPv4 and IPv6 also. But now I can separate the metrics for IPv4 and IPv6. I could make IPv4 go from the top path and make IPv6 go from the bottom path. Let's try and achieve that. So for going from the top path, I would go and increase the cost for IPv4 on the link to R3 to R4, on the link from 2 to 4, and maybe on 4 to 6 and 4 to 5. I would increase that cost for IPv4, but not for IPv6. So let's try and do that first. So on R2, I will go to my interface, gig 1.24, and say ISIS metric would be maybe 30. Let's also change the metric for R4 to have a higher metric towards R6 and towards R5. So interface gig 1.46, ISIS metric would be 30, and maybe on 45 also change that to 30. Again, the metrics are always outbound, so reverse traffic would probably take a different path. So I should do this on R5 also towards R4. So interface gig 1.45, ISIS metric, maybe 30, towards 56 as metric 30. And now if I go back to router 1 and do a trace route to 20.20.20.20, I should take the top path, which is from R1 to R2, R2 to R3, R3 to R6, to XR1 to XR2. Let's try the reverse path also. Trace route to 1.1.1.1. So I'm taking the top path again from XR2 or XR1 to R6 to R3 to R2 to R1. So right now for IPv4, I am taking the top path. Let's verify the IPv6 path also. So let's go back to R1 and do a show IPv6 route ISIS. And this is the loopback for XR2. And let's do a trace route to that loopback. So right now, even IPv6 is taking the top path, but I can make that go from the bottom path by changing the metrics for just IPv6. This is possible through multi-topology because separate SPF is being run for IPv4 and IPv6. So to achieve that, since I want the bottom path, I would go and increase the cost on the link between 2 and 3 and maybe the link between XR1 and R6. I would increase that cost for the metrics to be higher for IPv6. That's going to be done by going to my interface. So let's change the metric on R2 towards R3 for just IPv6. So on R2, let's go back to the interface gig 1.23, and I would say ISIS. Instead of me saying ISIS metric, which normally in single topology would be for both because IPv6 follows IPv4's path because they are one-to-one. But because now I have multi-topology running, they are completely separate, two separate databases, two separate ISIS or two separate SPF. So I could just say ISIS IPv6 metric and define a metric 30, which is going to be for IPv6. Similarly, I would go to my XR1 and configure XR1, go to router ISIS1, address family IPv6, or in fact, on my interface, which was interface gig 0000 towards R6, 619, address family IPv6, and here I can define the metric to be 30. Let's do a commit. So what's the effect going to be? Show run router ISIS. What I've actually done is I have changed the metric just towards IPv6, towards R6 to be a higher metric. The effect of this would be that my IPv6 traffic should take the bottom path. Let's quickly verify that. I should go to R4 also and probably change the metric towards R6. So interface gig 1.46 and say ISIS IPv6 metric 20. And let's do a trace route. So I'm going to go back to router 1, do a trace route for IPv4 first again. It's taking the top path 236 XR1 XR2. And let's do a trace route for IPv6. It's going from to 2, 4, 5, XR1, and then XR2. So it's taking the bottom path now. So you see, by running multi-topology, I could change the cost or the metric for interfaces for IPv4 separately and IPv6 separately, and I could have two separate paths. IPv4 takes the top path and IPv6 takes the bottom path. So to basically achieve something like this, what we did was we basically configured metrics on the interfaces. So we changed, because we wanted IPv4 path to be from the top, for IPv4 I changed the metric. So IPv4 metric was changed here to 30. I changed for IPv4 metric here to 30. And I changed the metric here, IPv4 to 30. So R4 would basically not go to R6 or R5. I did that for reverse path also. So my IPv4 traffic now goes from this path, which is my IPv4, and IPv6 goes from the bottom path, which is for IPv6. Now this was really not possible for in single topology because it's a 1-to-1 ratio where IPv4 and IPv6 take exactly the same path. But with multi-topology, I could separate that. Usually this is used for migration, where you had an infrastructure already running ISIs with IPv4 and there was no IPv6, but you slowly want to migrate to IPv6. So instead of disrupting your entire network, you basically start introducing IPv6. Keep the topology separate because you don't want your path to change for IPv4 also. So you keep IPv6 separate, you keep IPv4 separate. And once your migration is complete, then you can change it back to single topology. So it's 1-to-1 ratio, which basically makes both the path, both IPv4 and IPv6 path to be the same. I hope this video was informative to you, and thank you for viewing.